Polarimetry machines are used in chemistry in a wide variety of ways. Their main purpose is to measure the angle of rotation of an optically active substance using polarized light. This polarized light will either rotate clockwise or counterclockwise, and the amount it rotates will indicate the angle of rotation. Polarimetry is important in chemistry as it allows one to distinguish between enantiomers using optical activity as a measuring point. There are key tests in chemistry that are used for the identification of substances, such as the melting point tests. However, these tests are proven non-conclusive for the identification of enantiomers, as they have identical melting points and physical properties. Within the automatic polarimeter machine, there is a light source and a fixed polarizer. The polarizer will convert monochromatic, non-linear light into unidirectional light. As this unidirectional light passes through a glass tube containing an optically active substance, the plane of polarized light will begin to rotate. Finally, the rotated polarized light exiting the glass tube will be detected by the analyzer that measures its angle of rotation and produces a reading for the sample. The formula below illustrates the different variables a specific rotation depends on. The specific rotation is a literature value measured in degrees of any given chiral molecule. It can be found in scientific papers or online. The specific rotation is affected if the wavelength of light used to illuminate the sample changes or the temperature of the solution is altered. The main variables that can affect an observable rotation are concentration of the substance and the length of the glass tube containing the optically active substance. Prepare a solution with your unknown substance. Weigh out the desired mass substance. Record the concentration of your unknown substance in your lab notebook. Using a funnel, transfer it to a volumetric flask. Rinse the weighing tray and funnel with a glass pipette using deionized water. By using deionized water, fill the volumetric flask to its midpoint. Fill the volumetric flask up to the line with the glass pipette. Stopper the flask. Dissolve the solid by shaking the volumetric flask up and down. In order to find the optical rotation of your substance, you must first calibrate the automatic polarimeter. To do this, fill the sample holder using a syringe with deionized water. Draw out deionized water and insert into the proximal end of the polarimeter sample holder. As you begin injecting the fluid, be sure to maintain an angled orientation of the sample holder. That will help to ensure no air bubbles will be present. A waste beaker should be placed under the distal end to catch any spillage coming out. You may stop injecting water once the liquid can be seen coming out of the distal end. Cap the distal end of the sample holder, and then cap the proximal end after removing the syringe. Wipe down the vessel with Kim wipes, making sure the outside is dry. Remember to check for bubbles that may be present as it can impact your reading. Use a white piece of paper behind the sample holder and look through the clear lens. If you see a small white spot inside the lens, that means the holder is free of bubbles. If you don't see a white spot, then you must refill the sample holder correctly. Next, open the hatch in the machine and insert your blank. Note that the sample holder is placed between the two rails inside the machine towards the right side. Make sure the tube touches the right wall. Close the hatch and press 0 to calibrate the machine. After the calibration has completed, open the hatch and remove the blank. Empty the sample holder completely using a syringe filled with air and a waste beaker under to catch any spillage. You will repeat the previous procedure to find the observed rotation of your unknown substance. Pour sufficient amounts of sample from your volumetric flask and into a beaker. Using the same syringe, draw out your solution from the beaker and insert into the proximal end of the polarimeter sample holder. Don't forget to tilt your sample holder and use a waste beaker to catch any spillage. Cap both ends of the sample holder and wipe down the vessel with Kim wipes. Remember to check for bubbles that may be present as it can impact your reading. Open the hatch and insert your sample holder. Press start once the sample holder is correctly placed and the hatch is closed. Read the observed rotation from the display screen and write it down in your notebook. Open the hatch and remove your sample. Uncap and pour the solution into the waste beaker. Rinse the sample holder with deionized water and empty all contents into the waste beaker. Repeat the washes several times to ensure complete clearance. Ensure all apparatus components are properly sterilized and return to their designated location. If you are given an unknown concentration, you can calculate and solve using the formula given. Remember that the concentration units are in grams per 100 milliliters. You should also compare the observed rotation with various literature values. The chiral compound with the specific rotation best matching your experiment result is your unknown substance.